ஸ்டார்ட் பண்ணலாம் சார்.
ஓகே நீங்கள் ஆரம்பிச்சிருங்க ராம்தாஸ்.
Good evening everybody. Good evening Chairman Rajagopal sir, Council Member Rajamani sir, our Secretary Tamil Nadu State Center Secretary Kannan sir, and Narayan Sami Secretary Madurai Local Center, and other today guest speaker Engineer S. Vanilla Madam, Superintendent Engineer Tangetco, Metro Madurai. I welcome all the participants and today guest Engineer S. Vanilla Madam. Every year December 14th we are celebrating that Energy Conservation Day. In actually the IEI have 124 centers. In most of the centers today they are celebrating from morning different time. The same time a lot of other state center also, state center, local center also, they are celebrating that same Energy Conservation Day. So once again I welcome all the participants. Now I request Engineer S. Rajagopal sir, Chairman of Madurai Local Center, give the welcome address.
Thank you, Ramdas. Today we have got a joint meeting with the Tamil Nadu State Center and the Madurai Local Center on Energy Conservation Day. The topic of day itself is energy conservation. Today's chief guest is Madam Engineer S. Vanilla Madam, Superintendent Engineer Tangetco, Madurai EDC. Being the topic energy conservation, I think in Madurai, in our area today, we don't have any power now. For the past half an hour, we didn't have any power. It's also a part of energy saving, I think. I welcome all the participants. I welcome the Tamil Nadu State Chairman, State Secretary, and our Secretary, Dr. Rajamani sir, and other members who are participating in today's meeting. Thank you. Introduction, Narayan Sami.
Narayan Sami. Madam இது
இருக்கு சார் வேர்ட் இருக்கு சார்.
ரீட் பண்ணிருங்களா.
Before that we will ask our Dr. Rajamani sir.
Rajamani sir, our Electrical Division Board Chairman Mr. Rajamani sir.
He is muted sir. Sir Rajamani sir, please unmute sir.
சொல்லுங்க, நீங்க இத ப்ரோசீட் பண்ணுங்க ப்ரோக்ராம்.
Yes sir, I request you to say about energy conservation day.
So Energy Conservation Day is celebrated every year. Today as chief guest our Superintendent Engineer Tangetco, Metro Madurai, as a consultant. I thank him for coming forward and accepting our request to deliver a lecture on this topic. So energy conservation is not only celebrated this year, every year we are celebrating, we are talking to everybody, but the savings we get from this is to be considered. So repeatedly we are saying about the theme and we will have a certain effect due to this. So I request the madam to give his lecture on this topic and thank him for accepting our invitation. Thank you so much.
Narayan Sami, Secretary, கொஞ்சம் மேடம் இன்ட்ரோடியூஸ் பண்ணி வச்சிருங்க.
Okay. Sir, Narayan Sami, Secretary to the Madurai Local Center. I am very much pleased to introduce today's chief guest, Engineer S. Vanilla, BME, Superintendent Engineer Tangetco, Metro Madurai. He has completed B from the PhD College of Technology, Coimbatore, 1980-86. He has completed part an MBA from KRJ School of Management, Madurai. He has worked as a lecturer in Polytechnic at Coimbatore for 1 year. Started his career in TNEB as an assistant engineer in Tamil Nadu Electricity Board during 1987. Worked in Kadambare Hydro Station, associated myself in the commissioning of generating machines, a unique project in Asia for 3 years.
உங்க வாய்ஸ் கீழே போயிட்டே இருக்கு நாராயண் சாமி.
மைக்க கொஞ்சம் பக்கத்துல வச்சுங்க.
Worked in various places in Madurai as in charge of distribution, maintenance of electricity for 10 years. On promotion as assistant executive engineer, served in distribution and training wing for 8 years. During his tenure in the training wing, gained a lot of experience in designing, planning, organizing, coordinating, and conducting many training programs to engineers, accounts and administrative staff, and also for the field staff, both on technical and managing aspects. Trainings were conducted to public, industries, and also for students. On promotion as executive engineer, served in operation Alagoil and Pasmalai wing for 10 years. On promotion as a super engineer, served in Virudunagar EDC for 6 months, and at present working as SC Metro Madurai EDC for the past 2 years. By the request of Andaman and Electricity Department, imparted training to the staff of Andaman and Nicobar Islands for 15 years, which was well appreciated by all. There is achievements. Guided many ME students as an external guide on various topics, having exposure for many training programs, workshops organized at a state level and a national level on technical aspects and managing and financial aspects. Imparted training to police department officials, which was well recognized by the staff and the commissioner of police. As the executive engineer, operation evolved a lot of improvement proposals for EHT network improvement, new EHT substations, got approvals and executed most of the EHT line works in coordination with the GCC wing. A new 230/33 kV GIS at K Pudur for Madurai Metro areas got approved. Work is to be taken up. Involved in the restoration of EHT network in the around Nargul areas during OKHI cyclone and restored supply completely within 2 days. As SC, Virudunagar involved in the restoration of HT and LT network in and around Nargul areas during Gaja cyclone in Pudukkottai district and restored supply completely within 20 days. As SC Metro EDC Madurai, taken initiative to improve the HT-LT networks, form a ring main system to bring SCADA control into complete operations, was minimize outage duration and taking initiative to establish more substations to later future load growth. With this small biodata, I request Madam Engineer Vanilla to go for the lecture, sir. Thank you, sir.
Good evening, sir. Is it audible, sir?
Yes, madam, you continue.
I thank the organizers of Institution of Engineers for having given me an opportunity to interact and share my experience on this August week of energy conservation, which is normally celebrated from December 14th to 20th. So today morning, we have started creating awareness by printing posters, announcing through audio and also through video visuals to public. So energy conservation should not stop with the department alone. It should reach the general public to reap the benefits. So I take this opportunity to share my experience regarding this energy conservation, which we had been talking so long. So the concept of energy conservation has got two aspects. One is reducing the quantum of usage of energy, and also to have a discipline in usage of electricity, when to use electricity and how much to use the electricity. So when to use the electricity, we are now concentrating as DSM, demand side management. How much electricity to be used efficiently, we are concentrating on the part of energy conservation. So both added together will have a win-win situation on the part of the licensee, the supplier, as well as the end user, the consumer. So that is the main motive. So when we have a discipline in the usage of electricity, normally we face such crisis in the domestic sector when everybody uses their domestic appliances during the morning peak hour or the evening peak hour. There will be a shortage of demand, peak shortage. So we will have to go for power purchase at a higher cost, or we have to resort for load shedding. So when such unimportant appliances are being used at the non-peak hours, then this usage pattern can be this load curve of the distribution sector can be managed. That is what we are concentrating on. On the high tension industries, we are charging the peak hour usage at higher cost, say 20% extra. And when we use electricity during the non-peak hour, during the night time, we are charging at 5% rebate. So this is mainly to have a discipline on the usage of electricity, when to use the electricity. With regard to quantum of usage, we now discuss about the energy conservation. So the energy conservation, the present power scenario, we have in the recent past, we have developed a lot of infrastructures with regard to generation. Renewable energy sources development also has taken place. So the peak power shortage is now accounts to only 0.3%. We are managing mainly with the renewable energy sources. So energy requirement by 2021 would be 737090. The energy forecast from 1990 to 2019, for every 10 years, the demand is getting almost doubled. In the year 2022, the demand generation capacity was 1000 gigawatts in the all India level. In the 2020, it was estimated to be around 200 gigawatts. Now it is 2020. We are now, the actual demand met out is 373 gigawatt. So another 2 more years are left out. We expect that within the 2 years, the demand would be doubled. How are we going to meet out this demand with the available minimum resources? So the sources of energy would be from power grid, the central power, central grid share, state electricity board share, from the independent power projects, then from the renewable energy. The balance has to be met out by other means. So as the source is also getting deflected year after year, there is no possibility of increasing the installed capacity of the generation in the nation. So what else could be? So only tool which helps to manage the situation, to bridge the gap between the generation and the demand is to go for energy conservation. The objective of the energy conservation is to create and spread awareness and to motivate and bring changes in the usage pattern. That is what I had been talking about. All the unimportant usages could be shifted from the peak hour usage to non-peak hour usage. To reap the benefits, that's a win-win situation between the licensees and the end users. So energy conservation means utilization of energy available in economical and efficient way to yield the maximum benefit. Energy conservation does not mean the denial of energy for making life uncomfortable. It only means the available energy should be used efficiently. Using just quantity of power for a specific duration for achieving a desired result, and making continuous effort to reduce the energy consumption by employing energy efficient drives wherever possible by continuous evaluation of consumption and output. So energy conservation does not stop with just with the start. It has to be a continuous effort. Is it worth to conserve energy? Why we need to conserve energy? To make the world safer and to make our country brighter, stronger, and to be a superpower, and to make our society healthier and prosperous, to make our industries and homes smarter. To prove that every one of us are very responsible citizens, the energy should be made available for our future generation also. The GDP growth requires availability of surplus energy. Projected GDP growth up to 2020 is 5.4%. Energy intensity per unit of GDP growth in India is 2.1%. Capacity addition of new power plants should be around 12 to 15% over the generation capacities of the previous year. So what are all the sources by which we can have our power generated? It's the all India power scenario. The total thermal contributes 61% of our total installed capacity, out of which coal is 53.4, gas 6.7, oil 0.1. Hydro generating plants contributes to about 12.2%, nuclear 1.8, renewable energy is 24% of our total installed capacity in India. So we have a peak shortage of 0.3%. So we know very well that whenever we deploy coal, we have the emission of greenhouse gases, carbon dioxide 54%, CFC 21%, methane 12%, ozone 7%, nitrous oxide 6%. India has experienced dramatic growth in the fuel CO2 emissions, an increase of 5.9% since 1950. So 55% of the greenhouse emissions comes from the energy sector. So this is how the greenhouse emissions, where from we are having. Residential and commercial and other sources contributes to 10% of the GHG emissions. Other biomass combustions 10%, waste disposal 3%, power stations 22%, industrial process 17%, transport fuels 14%, agricultural byproduct 3%. So what are all the global changes that are brought in by this GHG emission? Is global warming a global warning. Higher sea level rise by 9 to 88 centimeters by the year 2020. Changes in climate such as severe storms, extreme heat waves, freezing of rivers, temperature rise up to 6%, reduced crop production, new diseases due to emerging infects, affects groundwater supplies, additional stress on wildlife and ecosystems. So what we think is, instead of increasing the generation, we could have a streamlining on the end user side by conserving energy so that we can reduce this GHG emissions. Energy shortage, healthier and prosperous society. Energy shortage brings unscheduled supply interruptions, poor quality of supply. In industries, productions are affected. Life of equipments are also getting reduced. Poor quality of product at a higher price, could not compete with the global competitors. Keep some quantum of non-renewable sources or fuels for the forthcoming generations. So we need to conserve energy to make the future generation also enjoy the benefits of the power sector. The resources of energy generation, power generation are also getting depleted day by day. Oil resource availability, they assume availability is only 30%, will be reduced to 8% by 2020. Coal resource, it will have only for about 230 years. Gas shortage resulted in underutilization of country's gas-based capacity of 10,000 megawatt. Another 4642 megawatt plants are to be commissioned soon. So all the resources, natural resources are getting depleted. So we just cannot go on adding the installed capacity of generation. Instead, we should go for economical usage of energy. Installed capacity of, as far as TNEB is concerned, thermal, we have 4320 megawatt, gas 516 megawatt capacity, hydro 2307, and non-renewable windmill 7854 megawatt. So out of which central share we have 6037 megawatt, IPP, independent power projects 5551, and from other shares 2624. So total we have got an installed capacity of around 29,212 megawatt as of now. So cost of generation from 3NEB plants alone is only 20.11%. Cost of purchase from outside is around 53.35%. Ratio of own generation to purchase is 1:2.5. And the average cost of supply is around rupees 3.47. So where are all the areas where we could conserve energy? Conservation of energy in industrial sector, that varies from areas to areas. Generally, electricity consumption as a percentage is more in industrial sector, though they are less in numbers. Number of consumers may be less, but their consumption is more, is around 38%. Agricultural sector, where we don't collect any money from them. Domestic sector, more in numbers, consumption is around 20%. Commercial sector, less in numbers, they are around 8 to 9% of the total electricity consumption. Electricity consumption as a percentage in industries, various types of industries. Iron and steel, 18%. Textile and aluminium, around 13%. Fertilizer industries consume 10%. Cement industries also 10%. Chemical industries 9%. Paper and sugar 4 and 3% respectively. This is also percentage of various activities in industries, lighting, electrolysis, and other electric melting furnaces. Energy consumption percentage in India, residential contributes to around 24.7%, industrial 41%, agriculture 17.69% on the all India level, commercial 8.24%, and others 8.15%. This figure reflects where are the areas where we could concentrate for conserving our energy. Mainly, we'll have to concentrate on the residential sector and industrial sector. Agri also we have started doing by providing capacitors. Energy loss reasons. Energy cost generally small fraction of total industrial cost, hence limited attention. Energy efficiency programs consider non-strategic and take low priority when the capital is distributed among various departments. So, apart from energy conservation, we are also taking a lot of measures in reduction of the energy losses between the sending and the user end. As far as distribution is concerned, TANGEDCO has implemented a lot of HVDS programs whereby we are reducing the length of LT line and increasing the HT line length, whereby the losses could be drastically reduced. And we are also started providing capacitors at the load end, say at the transformer end or at the consumer end, agricultural consumers, whereby the I is reduced, so I squared R is also reduced, so the energy losses could be minimized. This is also one measures which we are taking on the licensee side. So electrical saving potential on the industrial consumption versus the potential to save energy is around 25% in the industrial area, agriculture around 30%, transport around 20%, domestic and commercial sector around 20%. So in the agricultural sector, as far as agricultural sector is considered from TANGEDCO side, we are providing more number of distribution transformers, reducing the length of LT line. We are now going in for the concept of less LT to LT-less network. So no LT line, so that the I squared R loss is reduced. So the agricultural consumers are fed directly from the distribution transformer. And they are also provided with the capacitors so that the PF is also improved, thereby the loss is also reduced. What are all the ways where the energy could be consumed? Lighting, there is a technical saving of around 20 to 50%. Having low voltage fluorescent tubes, electronic ballast, CFL lamps, high pressure sodium vapor lamps, controls, daylighting. This is, we call it as a no cost measure. HVAC, building envelope, high efficiency chillers and heat pumps. And you have a technical saving of around 20 to 60%. Variable speed drive and maintenance would have a saving of around 20 to 50%. Heating areas, insulation, heat traps, solar water heaters, 20 to 70%, there is a possibility of saving energy. Refrigeration, multiple compressors, advanced compressors, variable speed compressor controls also, we have a potential saving of 15 to 40%. Other office equipments and intelligent controls, you have a potential of around 10 to 20% saving. So when we talk about energy conservation, we talk in terms of three types. One is no cost. The other one is low investment. The other one is a justifiable cost. So what are all the no cost measure of energy conservation? Simplest and easiest energy conservation technique would be make use of maximum daylighting. While construction itself, while constructing the building itself, give a scope for maximum natural daylighting to enter so that we need not use lights during the daytime. Make use of daylighting. Keep the computers and office equipments in energy saver mode. Do not put them in the standby mode. Buy Energy Star appliances, products and lights. Remove incandescent lamps in AC rooms, which will reduce the AC loads. Because you all know that in domestic sector, the tariff order, as per the tariff order, above 500 units, there is a drastic current consumption bill difference, around 700 to 800 rupees difference between 499 units consumption and 501 units consumption. Just one unit above 500 would change your entire current bill pattern. So if you could keep your usage in the houses below 500, your CC bill can be drastically reduced. Most of these consumers are paying huge current bills because of the AC usage. If we could have a discipline and technique of using proper usage of air conditioners, the current bill in the domestic sector can be drastically reduced. Most of the upper middle class are paying current bills in the range of 10,000 to 13,000 rupees just because of the usage of AC. Lighting and all other loads will not have much consumption. Only with the AC loads, they are paying huge current bill. So if they can understand the concept of using the air conditioners properly, then they can save a lot of amount in terms of payment as CC bills. That is what we are promoting today. Increase the usage of your AC by one, increase your AC temperature is air conditioner's temperature by 1 degree. There is a scope to save around 6% of energy. Avoid lighting more than what is required. This is what they call it as, or we have occupancy sensors. Where light is required, you have it. Where it is not required, you can switch off. So automatic adjustment of lighting by using control circuits called as occupancy sensors. Install electronic regulators in fans. Replace electromagnetic chokes by electronic chokes. Use solar lanterns and solar water heaters. So areas like Madurai, there is ample opportunity to use our solar energy. So we can make use of solar energy. TNAB is also promoting solar service connections by means of net feed-in system. Earlier it was called as net metering. That means whatever, if you install a solar power plant in your area, either in domestic, commercial or industrial sector, in the LT service connection, If you generate electricity and supply to TNEB, you use electricity from TNEB, the net difference between import and export will be chargeable to you. Earlier, all the consumers were enjoying and they were installing the solar power plant in their mainly in the domestic areas to not to exceed this 500 units slab. But now they have the regulatory commission has changed its policy and introduced a new solar policy called the net feed-in system, wherein the energy is not adjusted. Your import of energy from your solar power plant will be treated separately and you will be paid for the money for that as energy generated. And the usage of electricity for the units consumed from TNEB grid, you will have to pay separately. So now this is called a new system is called as a solar net feed-in system. Earlier we were calling it as net metering. So you will be billed for the difference between the import and export energy. So people were benefited much out of it because they were able to control the excess units above the 500 unit slab. So they were saving a lot of money. But now with this net feed-in system, the generation is treated differently and the consumers are paid for the energy generated, and for the units consumed from the TNEB grid, the consumer has to pay separately as CC bill. At justifiable cost, replace all the halogen and mercury vapor lamps by sodium vapor lamps. Purchase Energy Star equipments. Purchase energy efficient motors in place of standard ISI motors. Install soft starters in place of star delta starters. Avoid overcapacity motors. This we are experiencing in most of the industries. So they can install the motors to the capacity that is required for. Average standby power consumed by various appliances, PC monitors, washing machines. So VCRs, electronic ovens and cooking ranges consumes more standby power. Air conditioners are also standby powers. We normally don't switch off. We always keep the appliances in the standby mode. If you could switch off the power instead of keeping in standby mode, that itself will save a lot of energy. Heating and ventilation, where you could save energy by regular maintenance of all AC components, minimize part load operations, adopt variable speed drives for varying process loads, energy efficient windows. When you use air conditioners, in the windows, if you have glasses, if it is double glazed glasses, then there is a ample opportunity potential to save energy up to 50%. If you use AC, you can even go for false ceiling also. That also will conserve a lot of energy. Reduction of air leaks leads to percentage of energy saving from 5 to 30%. Check for leaks in ducts, pipelines every year. Insulate all core lines, vessels using economic insulation thickness to minimize the heat gains. So programmable thermostats also can be used to adjust the times you can turn on the heating or air conditioning according to a preset schedule. All smart air conditioners have come in. Even you can control the air conditioners even from your mobile. Fans and blowers, use higher efficiency fans, fan speed reduction by pulley diameter modification, impeller derating, energy efficient flat belts or cocked raw edges V belts for reducing transmission losses, improvement in duct system to reduce system resistance, change of metallic bar, glass reinforced plastic impeller by more energy efficient FRP repeller. So pumping system or pumps where you can have some modification, operate the pumps at best efficiency point, modify pumping system and pump closes to minimize throttling, repair seals and packing to minimize water losses by dripping. In case of over-designed pumps, provide variable speed drives or downsize, replace impeller or replace with correct size pump. Reduce system resistance by pressure drop, assessment and pipe size optimization. So normally when we purchase a pump, people are all bothered about the initial cost of investment. But life cycle cost means initial cost minus the energy cost minus the plus the energy cost plus the maintenance cost. So normally when we buy any electrical equipment, do not bother only about the initial cost of the equipment. Think about the energy cost, think about its maintenance cost also. Potentials of energy conservation in DG sets: ensure cold and dust-free air at intake, improve air filtration, ensure compliance with maintenance check, ensure steady load conditions, avoiding fluctuations, imbalance in phase, harmonic loads. This is with respect to motor maintenance in industries. For every 10-degree rise in operating temperature over the recommended peak results in time before rewinding to be halved. Let us not use rewinded motors in industries. It consumes a lot of power. Bearings and housings to be checked for wearing of bearings and to be friction free. Clean ducts and proper ventilation. Underloading and overloading to be avoided. Appropriate lubrication has to be done. Proper alignment of motor and driven equipment to be checked. Joints in the winding increases voltage drop and also losses. Capacitors have to be provided nearer to load. In many industries, we have seen that the capacitors are provided in the mains. So overcompensation is also not much of useful. So undercompensation and overcompensation should not be there. So it has to be exact. So we should provide capacitors nearer to the load in accordance with the motor capacity. That would be very, very economical and essential to conserve energy. Correct reactive power compensation. That is what I have told you. For according to the motor rating, you provide the capacitors. Motor to be operated more than 80% of the load. Streamlining of process flow. Isolation through MCBs. Fans with electronic regulators, savings up to 15%. So this is what comparison between the standard motor and usage of energy efficient motor. So the efficiency of standard motor is 78%, efficiency of energy efficient motor is 90%. Total losses in a standard motor is around 1500 watts, whereas energy efficient motor is 1225. So when you use motors, always prefer to have energy efficient motors instead of the standard motors. So advantages of energy efficient motor is reduces the size up to 40%, improves the power factor. Nowadays you don't have power factor incentive, you have only power factor penalty. So you have to operate the power factor at 0.9 and above. So it improves the power factor, improves water discharge up to 27%, saves energy up to 53%. This is also there. Minimize phase unbalance. Whenever we are using a three-phase system, there should always be a balance of loads in all the three phases. We have typically measured, we have concluded even in distribution transformers also, we have calculated the losses when there is an unbalance of load, and after balancing all the three phases, we have calculated the losses, it is very less. So there should always be a balance in all the three phases, which could reduce the losses. Effect of oversizing. This we are experiencing in the industries. Always they use a higher capacity motors than what is required. So select a motor which would exactly suit to the need. That would conserve a lot of energy. Potential to save energy in the compressed air circuit. Every 4% rise in air inlet temperature increases power consumption by 1%. Compression efficiency reduces by 2% for every 25 mm WC pressure drop across the filter. Worn out valves reduces compressor efficiency by 50%, so replace them whenever needed. If air demand is less than 50% capacity, go for small capacity compressors. Multi-stage compressors consumes less power than the single stage compressors for the same output. Reduce compressor delivery pressure wherever possible to save the energy. If process pressure requirement varies widely, say from 3 to 7 bar, separate compressor circuit may be designed. Keep the minimum possible range for load and pressure settings. Suitable diameter pipelines to reduce pressure drops. Compressed air leakage may go up to 40 to 50%. Have a periodical checking to be done. Ring main piping layout to maintain desired pressures to all users. Instead of lengthy pipelines for compressed air lines, small compressors may be installed at the far-off load points. Compressed air usage to be reduced to reduce the losses. So use of CFL in place of the incandescent lamp. Incandescent lamp 60 watts, CO2 emission 60 G per hour. If you have LED, you have only 5 watts. CO2 emission is also very, very less of 8.75 gallons per hour. This is a comparison between the ordinary incandescent bulb versus the CFL in terms of power, light, cost, life cycle, and number of hours it is used on. Scope for energy saving, provision of appropriate lighting levels. Certain locations are lit brightly than it is required. For example, if it's corridor, toilets, walkways, storerooms, usually we have 80 to 120 lux, whereas recommended is 40 to 60. So usually we are using incandescent and fluorescent. Instead, we can go for CFL or LED. The scope for energy conservation in the lighting is avoid group switching. This we are experiencing in many of the government offices where for 4 to 5 lights, they will have only one switch control. So avoid group switching. Switch off lighting wherever not required. This is the simplest no cost measure. Use task lighting. This they can use in many of the hotels and conference halls by using the occupancy sensors. Where lighting is required, you can it will be on. In other areas, it will be automatically off. Use light colored loose wave curtains to allow daylighting. So usage of energy efficient lighting, improved illumination, reduced power consumption. 3 numbers of 40 watts or 36 watts fluorescent tube lights can be replaced with 2 numbers 36 watts energy efficient lamp. Energy saving possible is around 35%. Installation of high frequency electronic ballast in place of conventional copper chokes. Energy saving possible in chokes is around 80%. So this is a typical case study where they have practically implemented and given a proposal. 2000 twin 40 in industry, 2000 twin 40 watts tubes in operation. Present lighting in manufacturing areas varies from 350 to 250 to 375 lumens. So power consumption per existing twin tube fitting, including choke, is 1 or 2 watts. So they had a proposal to replace the existing 40 watts tube lights with single 36 watts energy efficient tube. Power required by the proposed FTL, including choke, is around 47. Annual savings is 28 lakhs. Investment 2 lakhs. Payback period is 1 month. This they have practically implemented in an industry and they have just given the case study. This is what I have been talking about, the occupancy switches. Switches off bar on lamp according to the occupancy level. Energy saving possible is 5 to 10%. Optimization of lighting load by energy efficient gadgets, say that's power conditioner savers, servo stabilizers. So lighting feeder usually faces the problems like voltage fluctuations, unbalanced current, distorted waveform, poor power quality. Power conditioner saver rectifies all the above problems and there is a potential for energy savings around 20 to 25% in the above. mainly in lighting circuits in industries, if they have a proposal to change the conventional FTL to the sodium vapor lamp to LED or the fluorescent tube light to LED, they have a lot of energy savings. In an engineering industry at Chennai, the plant has 45 numbers 70 watts sodium vapor lamp. Illumination level needed with 100% illumination at all the peak hours, night 7 to 11:30, morning 4:30 to 6. So, and from 11 to 4:30, they want 70% illumination. It was suggested to install ChronoSense controller to even 70 watts SVL and also set time for switching on and switching off. So the light as per the climatic condition. Annual cost savings was around rupees 9,800. Investment required 33,750. Simple payback period is around 41 months. So use light wherever required, on and off according to the climatic condition. Avoid daytime lighting by installing transparent sheet. This also they can implement in all the industries. Shop floor lighting is switched on during daytime. Illumination survey was conducted during day and night time. The readings were recorded. Shop floor operates with 70% to 80% higher illumination during the daytime. Some of the other sections in the plant, no lights are switched off during daytime since they have transparent sheet. So they have proposed to install transparent sheet to switch off the light during the daytime. Annual saving was 12 lakhs. Investment 12 lakhs. Payback period was around 2 months. This is the MD controller, because if you exceed the maximum demand, you will have to pay penalty. So this also can be installed to monitor your loads. This is kilowatt control, automatic reactive power compensation. This can be installed in the industries at the load end. In TANGEDCO, we have provided this automatic reactive power compensation at the all transformer ends. So this also could reduce the current I, whereby we could reduce the I squared or loss. As I've already said, instead of the direct starter, we can go in for soft starter. Energy efficient transformers use an amorphous material, a metallic glass alloy for the core. The expected reduction in energy loss over the conventional transformers is roughly around 70%, which is quite significant. These type of transformers have increased efficiency even at low loads, 98.5% efficiency at 35% load. So use, instead of the normal iron core transformers, amorphous material, energy transformers. We also started this type of transformers. This is in the domestic sector, the opportunity to save energy in the refrigerator. A no-cost measure. Regularly defrost the refrigerators. Check air tightness of the door seals. Cover liquids and wrap food stored in the fridge. Keep some space between the fridge and the door. All these things need no investment. This is also simple no-cost measure. Consumes 20% of the domestic usage. Front-loading washing machine, reduce usage of hot water by 60 to 70%. Temperature setting of 45 degrees instead of 55 degrees. So we can use front-loading washing machines instead of top-loading. Water heaters consume an average of about 14% of our utility bill. Insulate electric hot water storage tanks and pipes. The thermostat should not be covered. Go for new water heater if the old one is been used for more years. Drain the water from the water tank for every 3 months. Take more showers than bath. Save water. Let your thermostat as low as possible. Energy cost of 40 watts tube light is around rupees 90 per year for 10 hours operation. Energy cost of 60 watts filament lamp is around 1,000 rupees per year for 10 hours operation. Energy cost of 1.5 ton window air conditioners around 15,000 per year for 5 hours operation a day. Energy cost of ceiling fan is rupees 1,100 per year for 10 hours of operation. So if we could keep this in mind in domestic sector or in commercial or in industries, we can have a suitable planning to conserve energy. Conservation of energy is not optional, but it is our bounden duty. Conserve energy and save the world. Conserve energy, strengthen the country. Conserve energy and build the society. Conserve energy, ensure future to our future generation. Thank you. Any questions?
Thank you, madam, for the exhaustive lecture.
Thank you, sir. Thank you, sir. Thank you.
Any question in the chat box? Does Dan Jetco adopt any energy audit process? That's a question, madam.
Pardon, sir?
Does Dan Jetco?
Yes, sir. Yes, and all the HT industries we had been mandating, sir.
It is mandatory. Is it Dan Jetco is doing it, or you will
No,
have
sir.
to...
We have energy auditors, sir, accredited by this Bureau of Energy Efficient, BEE.
Okay.
They are conducting the energy audit and they are submitting the reports.
Okay.
We are mainly concentrating on reduction of line losses, sir. From the licensee side. We are now concentrating on reduction of line losses, implementing more of HVDS, high voltage distribution system. That's what I said, less of LT line towards LT less system. So more of distribution transformers to the consumer end, no LT. Drastically reduces energy losses.
Okay, thank you, ma'am.
Okay.
Kannan? Mr. Kannan? Ramdas, Kannan,
sir.
Can you deliver a vote of thanks?
Yes, sir. Yes, sir. Very good evening, gentlemen and ladies. Madam, the PowerPoint close பண்ணிட்டீங்களா? Very good evening, gentlemen and ladies. It is my privilege and honor to say a word of thanks to the chief guest and the speaker of the day and all the members of the Institute of Engineers. The topic of the day, energy conservation, which is very important and after this period where there is a rapid progress in the industrialization, modernization, rapid growth of population and change in the lifestyle. It brought the need for energy is growing at a faster rate. Need for energy is growing at a faster rate, but the sources of energy are limited and the requirement to be consumed in a judicious manner, reducing the wastage. For this purpose, every year, December 14th, we observe the National Energy Conservation Day to remind all make an effort to save energy. First of all, my sincere thanks to the chief guest and the eminent speaker, Engineer S. Vanilla, Superintending Engineer, Tanjatco, Metro, Madurai. Thank you very much, madam.
Thank you, sir. Thank you, sir.
And very important, educative and very informative and advice to all to save the energy. Thank you very much, madam.
Thank you, sir. Thank you, sir. Thank you for the opportunity given.
My thanks to the Institute of Engineers, Tamil Nadu State Center, Chairman, Engineer Ramdas, Madurai Local Center Chairman, Engineer Raju Gopal, Honorary Secretary, Engineer Narayan Swamy, then who arranged an informative technical lecture in the restricted period. My thanks to Engineer Rajamani, past Vice President and presently the Council Member and other local center chairmans, Honorary Secretaries, members, lady members of the Institute of Engineers, who have taken their valuable time to participate in their virtual technical meeting. Thank you one and all. Thank you very much. Thank you, sirs.
Thank you, sir. Thank you.
You can we close?
Yeah, we can close, sir.
Yes, thank you.
Thank you so much, sir. Narayan Sam, sir.
Yeah, thank you, sir. Thank you very much, sir. Thanks a lot, sir.
We
And
can
we will-
close the, yeah.
Ramdas, sir. Ramdas, sir.
க்ளோஸ் பண்றேன்
Okay, sir.